Yeah, there we go.
Record.
There you got
Yeah.
it. Okay, so browsing debugging AOSP code. Yeah, so some people, it seems, like to use Android Studio, and some people like to do interactive debugging. Neither of these things are immediately obvious how you do with AOSP. And this is a thing that comes up in my training courses over and over, and I've always kind of never quite delved into it. So this is my opportunity to tell you what I've discovered so far. The key thing really, which I discovered quite recently, in other words, in the last few weeks, is that there is actually a tool that's part of AOSP which actually does most of the work for you. So this tool is called IDE Gen. You'll find out about it at this, this README file here has some basic information as to what it does. But essentially it's a tool which allows you to generate a project file, which you can then import into Android Studio, and then it understands your AOSP code base, and you can browse it and debug it. So, usual thing, we set up, run lunch, select your target, whatever it may be. Then you need to build the tool. You need to build a jar file. So you do IDE Gen, it chugs away for 2 or 3 minutes, and it generates a jar file. Next stage, you use that as part of a shell script to generate the project file and a module list. So you run that script as shown here, idgen.sh. This, for me at least, takes 4 or 5 minutes, and it spits out these 2 files in your $AOSP directory. So you get an IPR and an IML file. As far as I can tell, you have to redo this if you add directories to the source tree, because the module list is basically a list of directories. You would need to rerun this tool if you've added in, for example, a new device directory or a new HAL layer or something. Otherwise, it's not going to find it. Then you can fire up Android Studio. First thing is you're going to run out of memory unless you make a change. So you need to jump in and set the heap size to whatever number comes into your head, but 5 GB seems to be one that's often quoted. So you can either do this through the through Android Studio. If you go to help, edit custom VM options, and you put this text into the file there, or you can just go and hack it in directly. The file in question is this one down here. Notice that the path name here contains the Studio version. So this is the version for the latest one, which is called Chipmunk, released a couple of days ago, which is 2021.2 for whatever reason. Then you, in your Android Studio, you just open up that Android IPR file that was generated using IDE Gen. And it will then spend the next 2 or 3 hours indexing everything. So it's best to do this and then go away and have lunch and walk the dog and a few other things. But eventually when you come back, you should find it's indexed the entire code base. You can then do all the navigation of the code using your favorite Android Studio procedures. And as I said at the bottom here, some people consider this to be an improvement over Vim. As you can probably guess, I'm not so sure. I prefer using Vim, so I find Android Studio to be an absolute pain, but that's just me. So that's the browsing bit. So that's the kind of, we got halfway there. Then to do the debugging thing, you need to do just a couple more steps, and then you've got it. So first of all, I need to talk a little bit about JDWP, the Java Debug Wire Protocol. So this is a standard way of debugging Java programs, and Android uses this mechanism. you can see it. In fact, it's actually implemented in runtime as a thread. So you can see it here. I'm looking at, this actually is for the desktop application. And you can see we have the JDWP thread running here. Now, you only get this thread by default if you have an engineering or a user debug build, or you can enable it per application by putting debuggable true into your manifest. And obviously, if you build this under Android Studio in debug mode, it will do that for you automatically. One particular thing that we would be interested in, I think, is the framework, system server. So as you're probably aware, system server is the core of Android. It is a Java program which implements the majority of the Android framework functionality. So it's a huge, great chunk of code, and it contains all the really good stuff. Turns out this also has its own thread, and we can see it right there. As an aside, you can get a list of all of these processes, applications, and the framework that contain the debug thread. You can just type ADB JDWP, and it produces a list of PIDs. That's not quite as useful as it could be, because if you're just doing it this way, you need to go and relate those PIDs to actual programmers. So as you can see, I've annotated a couple of them here. For example, 765 is system server. However, there is a slightly neat way of doing this. For those of you who have been working on Android and AOSP for 10 years or more, then you probably remember DDMS, the Dalvik Debug Monitoring Service. It has fallen into disrepair. And most of the functions in DDMS don't work anymore. However, it still is handy for debugging. And it is part of AOSP, so it's still there, even though it's a bit rotted. It still works good enough for what I want it to do. So the nice thing about DDMS then is it gives me this nice list here where I get not only the PID, but also the name of the program, which is the bit that was missing from ADB. So I can run DDMS. I can see the list of processes here. I can click on the one I want, for example, system process. And you can see here it says 8700, and it's highlighted it in blue. That means it has, it's actually done a port forward for me so that I can attach to that JDWP thread through port number 8700. Okay, so debugging. In principle, then, we can use any debugger that supports the JDWP. So that includes most Java environments, including IntelliJ and Eclipse and whatever else. You can even do command line debugging using JDB, and I'll come back to that in a couple of slides' time. So all you need to do is to fire up your debugger, do an attach to a remote JVM on port number 8700, and away you go. And it actually works. So doing this within Android Studio, you need to do a couple of things. So you need to set up a remote JVM debug configuration. So go into Run, Edit Configurations, click on the remote JVM debug thing, give it a name. I called mine AOSP. And crucially, you give the port number here. Assuming we're using DDMS, as I am going to be, I set the port number to be 8700. Then I boot up my target device. So this can be an emulator or a physical device or whatever, doesn't really matter. So long as I can talk to it using ADB, I can debug it. Then I run DDMS. That will attach to the target over ADB. And I can then highlight the thing I want to debug, for example, system server. Confusingly, I forgot to mention this. if you come back to this slide here, it actually calls it system process instead of system server. Nobody knows why it does that, but that's what it does. So system process is an alias for system server. So do that in DDMS. Then in Android Studio, I just go to run and select the debug configuration I created previously. I called mine AOSP. Dunk, off you go. And if everything's working well, you should see a debug window pop up, and it should say connected to localhost, da da da. And then you're into debugging. I'm going to attempt a live demo in a moment or two just to prove this all works. In case it doesn't, let me just go on to the next slide. So that's using Android Studio, which, like I say, I'm not a huge fan of. Turns out you can also do a command line debugging, which is really my thing. So you don't need to, you can ignore everything I've said up till now. All you really need is JDB, which is just a standard part of the JDK. You don't need to install anything. You don't need to configure anything. You don't need to run IDHN and mess around. You can just dive straight in, type JDB. Well, okay, you need to specify the port number, which I'm not going to go into, but it's kind of trivial. And then you can do command line debugging pretty much out of the box. Command line debuggers are fantastic in many ways, but they do require quite a lot of typing, I've got to say. So in some ways, a graphical environment is maybe, I will ruefully admit, a graphical environment maybe is better for debugging. I was going to include that in this presentation. I kind of chickened out because I was running out of time and I wasn't quite sure how long these slides would take. So once again, I'll probably will come back to this at the next meetup. Okay, so if you'll indulge me for a moment more, I want to do attempt to do a quick live demo. So hopefully this is going to work, although I have a feeling it isn't. I pop that there. So this is a VM running my AOSP build. And if I've got it all set up on window. So I've got a cuttlefish image built and ready to run, which hopefully it's going to do. Dum, 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 dum. While that's launching, I'll come into this window here and I'll fire up Android Studio. So I have another little script that starts that up. This is the Chipmunk release, which is the latest version. Now, I've cheated a little bit because I've set a few things up already. And so if I come back to here, hopefully, yeah, here we go, right. So this is the emulator. If I just do the, I need to disable that lock screen. Okay, so what I want to do is to debug the, put a debug breakpoint on when you set the sliders to select the screen brightness. Don't ask me why I'm doing that. It's just a thing that I decided to do. So following my instructions, I should now be able to go over to here, run DDMS. As you can see, I've kind of prepared this already. Right, DDMS sometimes does this. You get question marks here. I don't exactly know why. But if you do actions reset ADB, that seems to fix it. Well, it did last time. There we go. So now I've got names of things, which is kind of what I'm looking for. Oops. And I want to set a breakpoint on system process. So I just click on that. It goes blue, and we see 8700 appears here. That means it's done the port forwarding on that port. And I should then be able to go back to Android Studio, go run, debug AOSP. Okay, so now we're in the debugger. It says connected to target, blah, blah, blah. So that all looks good. I've already set a couple of breakpoints. Like I said, I'm slightly cheating here because I pre-prepared this. But I'm mostly interested in this breakpoint here on set brightness. So if I now provoke that, so if I actually, that would have been a good idea. Let's go back to that. So if I go into settings, come on. This is a slow machine running on a remote server a long, long way away. So it's not the most snappy arrangement I could come up with. And somewhere down here, we should have display. Oh, Jesus. Come on, you can do it. There we go. Brightness level. Oh, it's going extra slowly. I think Android Studio slows it down actually. Come on. Come on, do something. There we go, right. Finally, we get the slider up, and if I slide this, this should hit the breakpoint. Really, it should. This is going extra slow. Is it because Android Studio is indexing everything down here? It seems to be using up all my bandwidth. Does anybody ever know if there's any way to stop Android Studio indexing the entire world?
I always find it very frustrating, Chris.
Sooner or later, this is going to work.
You can put on power save mode enable power save mode. I believe that cancels the index in the meanwhile.
Power save. Okay, right. I'm going to do it now. I didn't actually see it break into the debugger, however. For some reason, it wouldn't actually do the thing. I might just abandon this. Let's have one more go. This worked perfectly when I did the demo, when I did the rehearsal, rather. Oh, okay, for some reason. Okay, right. Right. At last, it's hit the breakpoint. The brightness level is some number, 0.256 something or other. And I can do things like stepping through code and continuing. It'll come back and hit the breakpoint again. For some reason, it always calls it twice. Okay. I'm rushing here, so I'm not going to go into. Okay, it's done it again. I'm not going to go any further than this. It's not that interesting. You kind of get the idea. We can set breakpoints in the framework code, and we can provoke we can exercise the device, and we can hit those breakpoints. That was my aim.